Assalamu alaikum. Bismillahirrahmanirrahim. My name is Janal Abdin and my metric number is MCS 202011. Today I'm going to presenting how the machine learning work. In AI project, final project. So I'm using a Naïve based algorithm for predicting heart disease. Yeah, I am using Jupyter notebook and Python language, and I implemented the Naïve based algorithm in Jupyter notebook. So first of all, we are using the few of the Python library. The and firstly with the numpy smp, import numpy smp. It's a Python library. This library is provide multi-dimensional array, and the next one is pandas library. It provides two-dimensional array, and it provides a concept of a data frame, which is two-dimensional array, similar as the Excel spreadsheet. And then third one is MATLAB plotlib. This library actually use the plotting the graph and the plotting the graph. Yeah, and the library Seaborn is also plot the statistical graph, mainly using the statistical graph for plotting. Yeah. So next we read the dataset. So by using this function pd.rd_csv, and we read the dataset, and our dataset is Hart Cleveland dataset, which is format is CSV. That's why we put here CSV. If it's the dataset is Excel, then we use Excel extension in the end of the read.exl. Now our dataset is CSV, so we are using CSV function here to read the dataset. So first of all, we run this library, and next we read the our dataset. So we run this code. So here you can see that it shows our dataset, where is 297 is row and the 14 column. And here we can see that in the dataset age, sex, CP and press BPS, cholesterol, and FPS means fasting blood sugar level, and so on. And in the last column is condition, which is our target variable, which means it's our predictor variable. So we are predicting the patient has heart disease or not by analyzing this all the variable. Yeah. So now we can check the data first. Five rows, five rows. Here you can see that we see that first top five variable by using this df.head function. And now we are checking the rows and the columns. So we run this code, and here we can see that our data set we have 297 row and 14 column, and this we can also see that the value of the row, each row, age, sex, CP, pressed BPS, call, etc., and so on. So this function shows the rows and the column and the shape of the data set. Now we can check the data uniqueness, and it returns the number of value from each variable. So it returns each of the variables. So now we are going to summarize our numeric variable. So we run the we can check the by using this function df dot describe function, we can see that the how many is the data set, and the mean, standard deviation, minimum value and maximum value. Yeah, so here you can see that in age the mean value is 54.54 and the maximum value in the data set is 77 and the minimum value is 29. So all the data are calculated as the same. So now we are checked is there any missing value in the data set. So we run this code is NF function. So let's run it. So we can see that there is no missing value in our data set, and so we check the value of our target variable. This is which is the last column of our data set, means it's our predictor variable. We can see the 0 is 160 times and 1 is 137 among the 297 rows, and this is the value of the zeros and the 1. So we are now calculate the correlation matrix. So we can calculate by core function, double R function. So we use this and we are plot this by heat map function in Python. So let's run it. So we can see that here is the heat map of our data set, and in the data set we can see that there is blue color, and in the center is white color, and in the top is the red color. So the blue color is close to represent close to -0, all the is -0, and the white color is so white color is close to 0, and the red color is close to +1, +1. So here is the picture, and here you can see that blue color variable like -42, -26, -0.27, -0.39, all are the close to the 0. And here you see the 1 is red color is 1, so 0.52 is close to 1, so it's positive, and blue value is all the negative. So in the white color, and all shows that it's close to 0. Next we can check the relation the heart disease and the ST depression. So ST depression means electrocardiogram, means ECG. So we are checking the heart disease based on the ST depression. So we can run this code. Here we can see that there is bar plot or box plot here. So in the left side of the box plot we can see that blue and the blue color and the orange color. Blue color represent the female, and one orange color represent the male. So here we can see left side in the box plot, there is positive patient with high median STD depression level, and on the right side we can see that negative patient with lower STD depression level, and we can see that male has the highest STD depression level. Yeah. So next we can see that filter the positive heart disease patient on our predictor variable. So we can run this code. So and we can see that in our predictive variable the mean value, the minimum value and the maximum value by the describe function. So we now filter the positive the value from our predictor variable, condition variable. So next we can filter the negative heart disease patient. So we run this code. So here you can see that condition if equal 0, so it means negative, so we filter it to pos underscore data. So we describe this data how it's look like. So we can see that here the mean value is 52 in the age, so standard deviation is 9.55 and minimum value is 29.0 and the maximum value is 76.0, and all the remaining are calculated in the same way. So now we can go the next step, and in the step we in this step we separate the column. So by using ilog function, and in the first we have 14 attributes. So in the 13 attributes we transfer, we take it into the x in x. So and the next step we the remaining our predictor variable we assign it to our y variable. So we print it x shape and the y shape. So we can see that in total row is 29 and 13, and the last remaining one is 29 297 and the remaining one. So we can print the our remaining the predictor variable how it's look like. So in our predictor variable we can easily see that our predictor variable is 00100 like that. Yeah. So now we are split out the dataset into training and the test set. So we can split this dataset. So we split into our dataset into 70-30. So 70% of data is using as training dataset, and 30% data is using the test dataset. So we use this test dataset split by using this function train underscore test underscore split function. So in the next we normalize the standardize the data. We transform the data so that it distribution will have mean of 0 and standard deviation is 1. So we use this standard scalar function. So we transform it x train value into the x train, and the x test value transform into the x test value, we assign it. So we are applying our Naïve based classifier algorithm. So we are applying the we run this code, and here we can see that a scalar matrix, it is a part of the scikit library, which library allow to use the many machine learning algorithm like Naïve based decision tree, all the algorithm. So we use this scalar dot Naïve based from import Gaussian Naïve based, means we are using Gaussian Naïve based. So we applying Gaussian and Gaussian Naïve based. So and we apply the to fit the train value, x train value and the y train value. So after that the model we can predict by the x test value. So we assign it the y underscore pred 4. So we print the classification report x test value and the x test report. So here you can see that accuracy is 86%. So our Naïve based algorithm is predicted 86%. So we are calculating the confusion matrix. So we run this code. So for confusion matrix we use the confusion matrix function of the y test and the y pred value, which is predicted. So we print it. So and the accuracy score we print it here 43 8 5 33. So here you can see that in the confusion matrix is that our model is predicted, our Naïve based model is predicted 43 is true positive, and the 34 amount of data is true negative. So it's our accurate confusion accuracy, and that is confusion matrix. So our model is predicted 43% accurate as a true positive, and 34% as true negative. So the error amount of value is 8 and 5. So here our model is predicted 8 amount of value is false positive, but actually it will be means positively false, predicted as positive as false. Actually it is negative, and the 5 error 5, our model is predicted as false negative, but actually it is positive. So we can plot this confusion matrix. So we can run this code. So we plot this confusion matrix in the similar way, then by the seaborn function and heat map function. And seaborn actually is is a library, and Python library which shows statistical graph, which shows the for showing the statistical graph. So so similar way, here we plot this confusion matrix. So now we are calculating the precision, recall, F1 score, specificity, and the accuracy. So precision is true positive divided by true positive plus false positive. So we calculated, so in the confusion matrix we can see that 43 is the true positive, and and false positive is 8. So we calculate the precision and the recall also. Recall is the true positive divided by the combination of the true positive and the false negative, and finally we can calculate the F1 score by multiplication 2 by 2 precision and the recall, and divided by the sum of the recall and the precision. So we can run this code formula. So here you can see that precision is 84%, and the recall is 89.5%, and the F1 score by F measure is 86.86%. So in the similar way you can calculate the specificity and the accuracy. So we run this code, and we can see that we can get the specificity is 80%, and the accuracy is 85.5, means almost it's 86%. So our model is predicted is 86%. Yeah, thank you. This is our we are applying the Naïve algorithm for predicting heart disease. Yeah, thank you everyone. Thank you.